Alright, you guys remember yesterday how we talked? Okay, y'all can put those down. Where do you want us to put them back there. We got to stage another picture, fifth period.
Oh.
Alright, so this right here is what you're supposed to be seeing. So like what you heard them saying, they're seeing rainbows. And the reason I didn't pass those things around, they are complete trash. They're absolutely the worst thing ever. Honestly, at Marshall, we got to do this in a physics lab to where you had to take measurements of these. And it's the actual process behind like identifying elements that's on a planet. So whenever they look at you and they can tell you what a planet is made of, and we've never visited there, ever, the reason why is because of this right here. They take the source of light coming from it, and there's two different spectrums you can get. The first one up here, this top, and I know it looks really blurry, but I wanted to zoom in so you can see. You see the black bands?
Yeah.
Okay, those black bands is the color bands down here. There's two different spectrums. This top one up here that has all this light on it, that is the absorption spectrum for hydrogen. Below it is the emission spectrum. So this is how they're using that idea. So like what we talked about yesterday is those electrons that go from the ground state and they go up to the excited state, and then they go from the excited state back to the ground state. What do they release off? Energy, which is in the form of photons. So with these photons, what happens, those photons are coming out there and they have an equivalent wavelength for these bands that we can see. So you can literally break it apart. There's like a piece of equipment, maybe in 10 years when I have everything that I desire, and I'm like, man, I would really like to have this fancy piece of equipment. I'll ask Mr. Stewart to spend the $800 for it. But till then, we're going to say, hey, can you buy me like 40 of these really cheap, dumb, stupid tubes that work really well? Because the tubes work really well because you guys didn't see this, did you? You guys seen the whole rainbow. The reason you seen the whole rainbow is because there's light coming in. So you got, but the tubes work so good, and honestly, it's the cheapest thing ever. I mean, it's literally like a piece of just a cardboard tube and lenses in it, and it works great. You see this spot up like instantly. You don't even have to worry about talking to a kid about turn your eye this way and move the tube this way or any of that. It just pops up and happens for you. So this is how they identify stuff that's on planets. And I like to cover that because I'm like, hey, this would be really interesting and really cool. The kids will probably really want to know about this. And the truth of it is, none of y'all probably do. You're just like, oh God, I'm dying in chemistry.
Mercury.
Close your eyes if you're watching the video. It actually got your hand. Good. Okay.
He said that's cool.
I think it's glorious.
Oh, well, he said that's cool.
Alright. Alright, I'm going to turn the lights back on. Watch your eyes. Alright, so in this, we are now going to break into something totally different today. And I actually need a certain periodic table.
Why certain? Why not just any periodic table?
It just works.
Oh, I got you. You need your periodic table.
Dude.
The one that you know and are familiar with. And have come to love.
Can we listen to Chick-fil-A?
No.
You're my Chick-fil-A.
I love how I update this thing and it like works at a slower rate.
That's how iPhones are.
They must have come out with a new smartphone.
Mr. Stewart, I want the new one. It'll be like whenever we go over the periodic table.
Is that in
It won't be the next quiz. It'll probably be right before break, or it's going to be like after you get back from break. Thanksgiving break.
Oh my goodness, that's good.
What is it? No. I don't care about the order, guys. Okay, look, because I'm going to get this question 1,500 times. I've already got it 6 times since I brought this up yesterday, and I addressed it yesterday whenever I said it. I don't care if you know the order they're in. Okay, you're going to get used to where they're sitting at on the periodic table just from having to use them. And I give you a periodic table all the stinking time. So in this, you already know where they're at. I need you to know the chemical symbol, and I need you to know the name.
Okay.
Why? Because whenever we break into nomenclature, you have to know the symbols in order to give me names of compounds and molecules.
The symbol's like just the letter.
Yeah, that's it.
Hydrogen is H.
That's it.
Helium is.
And it's not bad. It's really not bad. Like, there's a couple trick ones on there that I'll throw at you, but literally, just focus on them a little extra.
Lead is PB. Plumber.
Lead's one of them. Mercury is one of them.
AG is
HG.
HG. That's something G. AG is. I don't remember. AU is gold.
They use gold.
AG is silver.
Silver. Ain't gold.
Oh.
That's how I remember it. Alright, so in this, today we're going to start on something new, okay? This is going to break us into this quantum model of the atom. Now I have to say this first and foremost. I'm going to introduce you to some things today. I'm going to give you what these things are based off of. We're talking about our electron configurations. When I'm talking about these, I'm going to introduce you to something, but I need you to do me a favor.
What's that?
Just accept it.
Okay.
It doesn't matter how I go, because you have a choice. You're dealing with electron configurations, or you're going to deal with quantum numbers first. And either way it goes, if we do the quantum numbers first, everyone's like, why does this matter? Who cares? What's this all about? And when they're like, where are these things? And you do the electron configurations, you're going to be like, where's all these things coming from? You just have to accept it at this point. When we get to the quantum numbers, it makes it a lot simpler. I found in years past, if I do the configurations first, you all are so curious about where these things are coming from. When we get to the quantum numbers, you're like, oh! That's what that number is. So it works a lot better. Okay? So in this, I'm going to give you the breakdown of it. Electron configurations. There are 3 different types of configurations that you'll deal with. But the important aspect of it is electron configurations is important because within chemistry, we care where the electrons are. We also care what those electrons are doing, how they're interacting, how they're doing stuff, okay? So you have 3 different types of configurations. I'm going to give them to you. The first one, we call it an orbital notation, and this is the one we'll start with. And this is one of those things where, you remember me asking you to just accept it at this point? Just accept that word orbital. We'll break it down a little bit later. But within these, you know those energy levels that we were talking about? And we said those electrons are in those energy levels? And it's like those energy levels are in circles. The truth of it is inside those circles are orbitals. And they have all sorts of like weird, different, funky shapes. And that's where we're finding these electrons to lay at. Alright? So the first one's orbital notation. We're going to start with it, and the reason we start with it is because we're going to break it down and make it a little shorthand when we do a electron configuration. I know that sounds repetitive, but there ain't no other way to really introduce what this is besides saying, hey, we're going to do electron configurations. And then I'll personally promise you and guarantee you the third one will be your favorite. It's a shortcut.
I like shortcuts.
Noble gas configuration. Alright? So I need you to accept some stuff. Within these electron configurations, there's 3 base rules that we base everything off of. And they literally travel like this. It's going to be off-ball principle, Pauli exclusion principle, and Hund's rule. And if you guys want to see somebody that looks like a toad in the face, and you're like, ugh, that's a face a mother couldn't even love, I challenge you to look up this guy that came up with this principle. His name is Wolfgang Pauli. You may puke.
That's a cool name, though.
Yeah. And then you look at his face, and you're like, oh my gosh.
That is very good. Why don't you do a picture of them?
Video.
Because I don't want to have to live through that horror ever again. No. Alright, so in this, we're going to go through in every one of these rules. The important aspect of it is you know what these rules are, what they're about, what they state for. So first we're going to talk about is the off-ball principle. What is the purpose of the off-ball principle? It's simple. The whole purpose of the off-ball principle is it gives us our field order. I know right now that doesn't make sense to you. You're going to figure out today what field order is all about. Okay? So within this, this is what's said. This is what the off-ball principle states. An electron will occupy the lowest energy level that can hold it. So you guys should be okay at this point. Remember those energy levels we introduced, those circles.
Yeah.
Okay? 1, 2, 3, and I told you it goes all the way up to 7. Okay? You should be fine there. This electron wants to occupy the lowest energy level. Why? And this is the simplest way to explain it to you. Electrons are lazy. Okay? It's like it's going to choose the first possible seat it can. It does the opposite of what you, like high schoolers, want to do. Like if we get on the bus and there's 10 of us and there's 48 seats on the bus,
We're going to the back.
where y'all going to go? Y'all going straight to the back. Because you know me as the teacher, I'm going to sit right in the front. I ain't going back there to the back. That's nuts. Y'all going back there, you're like, I want to be away from you. They're completely opposite of you. They're like, man, I'm lazy. If they get on the bus before me, they see the first seat available, they're going to take the first seat.
They're sitting on the
And then when I walk in there, they're going to look and say, I was here first. Snooze, you lose. Move on, Mr. Hall.
Mr. Hall.
Mr. Miyagi.
All right. In this, there's 2 ways to get your field order. I'm going to show you both ways. I absolutely hate one. My favorite one is with the periodic table. I'm going to show you the first one first, okay?
The first one first, that's amazing.
I know, really. I hate this one, but there's an important aspect that you got to get with this, okay? You're just going to have to bear with the camera flipping around. On this, on your periodic table, and I will give you a new periodic table. You will have to have this one, but I want to show you the breakdowns of it later on. So in this, you have to understand the periodic table can break down into 4 blocks. I feel like I'm talking about prison whenever I'm talking about this. So you got 4 different blocks. So the first one you got is right here. It's the first 2 columns there. The first 2 columns are what we call the S block. From here, you will go over here, and you're going to find out why you get these down here at the bottom now. From columns 13 to 18, all the way over, is a block. This one is It's called the P block.
Peabody and Sherman.
It's actually a really good movie.
They're
I
not.
love
It
that
was a
movie.
good
Do you have any fans for the food drive?
Right there they are.
They're going to be an H block.
No, there's not going to be an H block. So in this, you got the S block, and the P block. Now the key to these are the S and the P are what we call the main elements. These are the elements that within this class you're going to deal with on a consistent basis, and you're going to have to work with them. Now from here, you have column 3 to column 12, all in the big part is block. This is D block.
Is it the block?
Ha ha ha.
D block. I like it. And then you have the last one, and these are the weird dudes. They're freaky. Okay, there ain't no other way to say this.
They're
Besides,
Seg.
the guys down here, they're in solitary confinement.
Oh, that block is poison.
And they're called F block.
Oh, I'm sorry.
Keep it clean, Maddie.
We're trying to post this one.
Okay? You need to understand the breakdown of that before we get over here, because then you all are going to be like,
Hey.
what?
On a keyboard, it goes ASDF, and then you just got P showing out.
So now that you got that, let's go back up here. And I know right now all of you are sitting here confused, and you're like, this makes no sense, Mr. Hall. What are you doing? You're confusing me. I understand that. You have to understand the aspect of what you're looking at here. Okay, so in this, we're going to teach you, here's the first method. And this is probably the one that over half of you in this room is going to choose. And I hate it. It drives me insane. I despise it. I feel like it is absolutely the worst of the two options, but I give it to you in case it helps you. The key to this is knowing what numbers they start with. Okay? So the key to this is knowing that S starts with 1, P starts with 2, D starts with 3, and F starts with 4. It's going to make sense here in a minute.
Electrons.
So you're starting with the S. S will go 1 through 7. So in this, you're going to create columns. So this is the key. You're going to create columns if you want to use this method. So within this, you go 1S, 2S, 3S, 4S, 5S, 6S, and 7S. Then you stop. Then you're going to go to make a P column. When you go to make a P column, where does P start? So you go to the second row. You start at the second row, 2P or not to P, that is the question. Mark it down across the curriculum. We covered English today. Here we go. Got it. Got our AC. We got our SAT study in right there. People got me.
Gotcha.
Cool.
I'm fine with that.
We do the math all the time. Now we're doing English. Then we go 3P, 4P, 5P, 6P, and 7P.
Let me guess. D's gonna start on 3.
D is going to start on 3, but this is the thing when it changes. When it goes to D and F, stuff changes.
Stuff gets crazy.
Okay? So within this, understand, you get here at D, it's going to change. You're going to start at 3, but you're not going to go all the way to 7. There is a 7D, but we don't use it.
Huh.
There's no electrons ever in it.
Ever.
Ever. Like, you go all the way over on the periodic table to the very last element, and it does not, there is no electrons within the 7D, ever. Farthest it'll go is the 6D. So we go to row 3, like you said, Maddie. Starts at 3, we go 3D, 4D. That's time, by the way. 4 3. 5D,
6 time machine.
6D. You stop. And then, remember what I told you, okay? The F orbitals, they're freaky, okay? Black. In this, it will start at 4, but it's going to end real fast. It's going to end at 5. So 4F, 5F.
It looks like an arrow. Kinda.
And now this is where life starts to get fun. I'm going to write the fill order all the way over through here. It does not fall under Paul exclusion or 100 rule. So don't fill this in under this. Just keep it rolling with your paper.
Okay.
Here we go. Fill order. This is the order you will use whenever you're dealing with doing these configurations. So, all you're going to do is draw arrows. And you start at the back of where no arrow is hitting anything yet. So the first one, no arrow is hit, 1S. And we draw an arrow through it. So the first thing in fill order, 1S. You need something?
No, I'm done.
Oh,
Sit
this is
on
gonna
laptop.
be cool.
Alright, from here, first one that hasn't got hit, 2S. So we draw an arrow, it goes through 2S.
Is there a comma or is
It'll just, we're just going to roll through. You can put commas if you want. Is it going to drive y'all nuts if I don't put commas?
it?
You stinking English people. Miss Steffi's teaching you right.
Would it be 2P with 3S?
There you go, 2P, 3S. Where are we going to go from here? 3P, 4S. This is the key. Watch how the arrows are going. Don't just like copy this down. If you're not understanding where the arrows are going, tell me to slow down because that's the important aspect behind this one. So 3P, 4S, 3D, 4P, 5S. So arrow goes through. 3D. 4P, 5S. That is a 5, not an S. That's an S next to it. Continuing on from there. You go 4D, 5P, 6S. Everything's about to get freaky now.
You gonna change it up?
5P, 6S. This is where the change will take place. 4F, 5D, 6P, 7S. 4F, 5D, 6P, 7S. Starting to run out of room. And then to finish it off is 5F, 6D, 7P.
You said it would be
5F, 6D, 7B.
That's impressive.
Thank you. That's the first order. Okay, that's the first option you can do to get your field order. Okay, I know a lot of kids like to use this because as soon as I give them the periodic table, they'll take the periodic table, flip it over, they'll draw this out, and do the arrow method. The only issue with this is if you use the arrow method, you're going to get jacked up if your arrows are off. If you do not do the arrows right, your arrows will mislead you. The key to it is there's a little pattern that I like. Watch how the numbers go after the S's. After an S, when we get the change, 3D, 4B, 5S. 4D, 5P, 6S. 4F, 5D, 6P, 7S. And they'll keep going like that. Now the important aspect of it is, this is the order in which you're going to fill with these electrons. These are how the electrons fill within these orbitals. Okay? Any questions? No questions? Let me show you option 2. Option 2 is my personal favorite. Option 2 deals with the one thing that I will always give you on a quiz, except for your element quiz, the periodic table. And you literally use it as a road map. So this is how I like to use it.
I like maps.
Me too. Especially when they're chemistry maps.
Those I have a whole atlas at my house.
Alright, in this, here's the periodic table. Now to do this, I got to take all this off. You need to memorize and know where the S block, P block, D block, and F block is. Where am I getting those little numbers of the letters from? It's the orbitals that's coming from here. I'm going to show you my personal favorite method. This is what I like to call the road map. This is literally what you're going to do. The important aspect of it is knowing a couple things. First off, helium actually doesn't sit over here in this case. Helium is going to act like it's sitting right here where that 2 is. Because that's what makes it fit to get your fill order in. So in this, here's how you're going to start. It's a road map. You start with hydrogen and you just keep traveling. And you keep going in order of how things will roll for you. So in this case, we're going to start at hydrogen. And the key to it is using the rows. So in this case, what row is this? 1. Okay, so here's 1, there's 2, 3, 4, 5, 6, 7. Here's the important aspect. This right here, you see that 57? Oops. Look where the 57 falls in at. So what's the row for here?
6.
6 and 7. Okay? Now with this, whenever you're looking at it, the number that goes with the block is equal to row.
Wait, what?
Mr. Hall,
Yes,
I never noticed that there was not the 117.
there is.
There is?
This is an older periodic table.
I was getting ready to say.
Yeah, all of them have names now. There's not one of them that's unnamed. So here's the important aspect when you're dealing with the fill order. If you're dealing with S, the number before is equal to the row. For P, it's the same thing. The number is equal to the row. But it changes for D and F.
Of course it does.
For D, the number is equal to row minus 1. Now, before anybody screams at me, yes, I know I promised you we're not going to do more math in this. If you're struggling with this mathematics right here, come see me during lunch. We'll go talk to a counselor and see how possible it is for us to get you out of the class because you're struggling with subtracting 1. I think everybody in here can do this. Okay? It's not major math. Same thing for F. F is number equals row minus 2. I'm going to use this fill order to show you. In this, the fill order up there, rolling through, is going to be the same thing we're going to get from here. So, whenever you look at your periodic table, What did I just go through? Row 1, which block?
S.
S. So what do we have first?
S1.
1S.
1S, yeah.
Okay? We're done through the first row. So we go to the second row. What block did I just go through? S, 2S. 1S, 2S. What comes after that? There's nothing here in the middle, but boom. P block. What's the number? 2. 2P. How'd you get the number?
Because we're in the second row.
You're in the second row. The number for S and P equal row.
Wow, that's crazy.
So in this case, you got 3. Third row. Boom. Where'd we go?
3S.
3S. Nothing here in the middle. 3P.
P.
3P.
Go from 3P. Has anything changed up there? Are we still
No.
rolling? Is it still the same?
4S.
What row?
4S.
What block?
S.
Now watch the change.
D minus 1.
We now have something here in the middle.
It's the row.
The row.
It's the row.
In this case, what's the number that's going to go with this? We're in the D block.
3.
3. How did you get that?
The row minus 1.
The row.
You're in 4.
Minus 1.
How did you get the row? 4th row, row minus 1.
Bring the Smith to the office.
So you're dealing with 3, and you're in the D block, so it's 3D. Now you stop here at 12. Remember, 12 is that cutoff
You're
point.
entering into another block.
You're entering into another block. You enter into the
P block.
4.
P block.
4P.
4P. Man, y'all catching on so fast. I may cry today. Y'all
This
making my
is the
day.
better method.
So here we go, 4P.
That's because this makes more sense.
Yeah. Like,
Is this a whole different method?
you gonna see me writing.
It's part of the
on my-
unit.
On my periodic table, I'm gonna just drawing lines.
It's what I want you to do. It honestly works
I
great.
have a question.
From
I'm
4P,
gonna block
look here. Don't look up there. Look here. Don't look up there anymore. Where are we going? We go
5S.
into the
5S.
5S because it's the 5th row. We just went through the S block.
Yep.
Oh, now I'm in the D.
So it's D
The
minus
row
1.
minus
4.
So it's row minus 1, which is 4, and it's the D block, so it's
All the way to 12.
4D. You go to the 12th column.
Back
Y'all
to
catching on so
5.
fast, y'all are like jumping ahead. I'm like, so
5P.
5P. Why is it 5P?
because we went back in P.
We
You went back in the P block, which means it's a P orbital, but
We're still in row 5.
you're in row 5.
I have something.
What?
What if the row stole one and then he felt guilty and he gave one back to the P?
Ooh. Or.
If that helps you, go for it. All right, we're going from 5P,
6S.
6S. Here's the key, and this is the part where I catch people. This
You're
is
in
a
the-
trick, but it's not a trick.
You're in the
What's the
left
number?
side.
Solitary
Right there is the F block.
You're going to go to the F block. Guys, the key to this is why I like using this periodic table, is right here it tells you, just look at the number, 57. Well, there's 57. You go down first. So what row are we in?
D.
We're in the F block. Well, what row?
6.
6.
Subtract 2.
Minus 2 gives you
4.
4, and you go through the F, so it's 4F. Then from here, where do you go?
Back to D.
No, you go to D row.
You go to D, because you just went through this.
Yep.
So now we're going to go through the D.
Yep.
6.
6
it 6D?
This is minus 1. So it's
5D. That's how I get people. That's how I trick them.
You didn't trick us. I was just explaining.
5D. Go all the way to 12. What comes after that?
P.
6P. From here,
7.
7S, because you go through the
Yep.
S
And you
orbital.
drop down to the F block.
We're going to drop down again. Look at that number, 89.
It's going to be 5S. Also, you
5F.
Jump back up to the D block.
Jump back to the D.
And then it's going to
Is
be
D is minus 1, so you go
6.
6, 6D.
6D.
All the way over to 12.
all the way to the 12th column. Stop.
Got 7P.
7p.
And then 7p. You're done. Question to you. Is there a difference between what I just came up field order from looking at a periodic table that I'm guaranteed that I'm always going to give you and that field order up there?
I don't believe so.
We can go.
There's not a difference.
That's
Because
I don't
look,
think
follow with me. You watch up there. I'll read it off here. You ready?
Yep.
1S,
Yes.
2S,
Yes.
2P,
Yep.
3S,
Yep.
3P,
Yep.
4S,
Yep.
3D,
Yep.
4P,
Yep.
5S,
Yep.
4D,
Yep.
5P,
Yep.
You can make
6S,
Yep.
4F,
Yep.
5D,
Yep.
6P,
Yep.
7S,
Yep.
Mr. Hall,
5F.
wait a minute, we're sundown.
It's not in
She's
here.
not in here.
What are we in?
We're in second.
Oh, I'm a little ahead of myself, thank you.
You're fine.
Should I enter
Where was I at?
6D?
5F, 6D, 7P. Is it the same?
Yes.
You choose the method that works for you.
That one.
I like the periodic table especially because some questions that I ask you later on. How's everybody feel?
When we go to the F block, can we just count down 2 rows? And just be like, well, that's mine.
You can, but not strongly recommended.
Oh, shut up.
Alright, then I'm going to give you this one. We'll have to wait for Hun's roll tomorrow.
Oh, God.
But within this, yes. Oh.
Oh, wait, I made that in my other classes too. I have to buy all of my grades, Mr. Hall.
You have to buy all your
I have to buy all of my grades. Thank you. Bye.
Paul exclusion principle. This is the one that I love the most that everybody's like, what? Paul exclusion principle. This is all it states. No electron
Can you please report for the office?
in the same atom can hold the same 4 quantum numbers. You do not know the 4 quantum numbers yet. You will learn them at a later time.
That's
But
why you
within
asked.
this, the important thing of it is to know Pauli exclusion principle states no electron in the same atom can hold the same 4 quantum numbers. It's not possible. If I take an atom of carbon, within it, it has 6 electrons. All 6 electrons will have 4 different quantum numbers.